Mr. Kant wants to do null set. And so my statement for null set is if everything is aqueous, comma, then everything, will cancel. And so people were asking on the lab, they're like, well, do I just leave it blank? No. So let's say don't leave it blank. There's an answer we can give. What's the answer if everything cancels? If everything cancels, the answer is you say no reaction. You specifically say there's no reaction there, right? So you could have A plus B goes to no reaction, okay? That's what I want to see, that you recognize. You don't just leave it blank, that you can show me, demonstrate that you recognize that that's not a reaction, okay? Let me do an example. How about calcium chloride with potassium nitrate? I think I did this in the lab. Is it okay if I'm repeating stuff I did in the lab? I hope you guys don't mind. Okay, so when I write this, okay, so someone wants me to go through a question from WebAssign homework. Yes, I will. Some of us only have the lecture. Yes, so that's why I'm repeating this. I think so some of you might be bored with this but that's okay. I mean, you might want to just watch it again anyways, because I think it's, anyway, so let's continue. Absolutely. Let's continue. So calcium chloride, we broke this one apart before. It's calcium 2 plus, 2 chloride minus. This is very similar to the silver nitrate. It's potassium plus and nitrate minus. When they switch partners, potassium's going to go with chloride, calcium's going to go with nitrate. So my products are calcium nitrate. This was actually from the first one, and this is a +2 and a -1, so it's got to go 2 nitrates to make a 0. And ignore the coefficient with the chloride. I have +1 and -1, and I want potassium. I want the metal first, KCl. So those are my products. And so I get to calcium chloride plus potassium nitrate goes to calcium nitrate plus potassium chloride. And then I want to balance it. If I look at this, I have, well, the metals are all one potassium on each side, 1 calcium on each side. The chlorines, 2 and 1. So I'm going to put a 2 here. And then that changes the metal. So now that I have 2 potassiums here, I'm going to want 2 potassiums over here, which that's kind of good because that gives me 2 nitrates, which balances the nitrates. Now it's balanced. Let's go to the states. So this is aqueous. This is aqueous. And then if I look at nitrate is always aqueous, no exceptions. And potassium is a group 1A cation. It's also aqueous, no exceptions. So this is my balanced equation, right? I got that far. That's finishing step 4. When I go to the total ionic equation, everything gets written as ions, right? I have calcium 2 plus aqueous. This is tedious, but I'm going to do it anyways. 2 chloride minus aqueous plus 2 potassium plus aqueous plus 2 nitrate minus aqueous goes to calcium 2 plus aqueous plus 2 nitrate minus aqueous plus 2, let me bring that up, potassium plus aqueous plus 2 chloride minus aqueous. So what cancels? What cancels? Anybody? I see
2K,
calcium.
Yeah.
Calcium's
2K.
gone. Chloride's gone.
2K.
Oh, potassium's gone. It's all gone. There's nothing left. So this is why you can think of it as a null set. So what you need to write is for your net, the answer to the net is no reaction. You can show this as your total ionic, right? You can do the balanced equation, the total ionic, but for the net, you better say no reaction because there's nothing left.
I have a question about this for the lab worksheet that we're doing. And
Yes.
it's asking us to do this. If we can just predict using the solubility table that there's going to be no reaction,
Yeah.
do we still
If
need
you
to do
guys get
all
up
this?
to here and you see aqueous, and these are aqueous, you can just say no reaction. You don't have to go through all these steps.
Okay. So, like, how about if we're using the solubility table? Do we need to even do the first step?
Yeah, if you want to, so for the lab, you can say, whatever, CaCl2 plus KNO3, no reaction, and I'll accept that. Why did Mr. Canton do all this? Well, because you can reason your way out of it. And to me, this kind of proves my case at the end. So I basically wanted to prove it to you. But yes, you can take the shortcut. I said that in the lab period too. So I'll stick by that, okay?